When you build software today using AI, you aren't just using one tool. You might have Claude designing the architecture, Gemini monitoring a video pipeline, and Cursor reviewing the code. You have immense generative power at your disposal, but it's trapped inside disconnected applications. Because these agents cannot talk to each other, the human developer becomes the bottleneck. You spend your day acting as a messenger pigeon, manually copy-pasting log outputs and code snippets from one isolated chat window to the next. This isolation creates friction. Without a shared context, agents blindly edit the same repository, leading to overwritten files, broken node architectures, and silent bugs that fail without ever throwing an error code. Possessing high-level intelligence is useless if the system lacks a way to coordinate. If keeping your AI assistant synchronized takes more effort than writing the code yourself, the development process is no longer sustainable. Eventually, you have to stop trying to outcode the friction. Instead of patching errors as they happen, you pause the project to manually record the mechanics of every silent failure and edge case you encounter. What begins as a messy set of troubleshooting notes starts to map the specific vulnerabilities of the environment. You begin to see patterns in how VRAM leaks occur and how different models handle complex JSON structures. By treating the failures as the primary subject of your work, your perspective changes. You move from being an isolated coder reacting to bugs to a systems architect designing a way to prevent them. A markdown guide is a helpful reference for a human, but to be truly effective, it has to be machine executable. The manual notes need to evolve into a formalized, parsable database that an AI can actually use. The Custom Note Survival Guide is a 94-entry database categorizing architectural failures by symptom, cause, and fix. This enables an automated regression suite. It cross-references a codebase against all 94 entries in under 2 seconds via static analysis, identifying bugs without launching the runtime. Turning these errors into code transforms personal frustration into a preventative shield. It ensures that the community doesn't have to repeat the same 3-hour debugging sessions just to find a single encoding error. If we can automate the verification of bugs, the next step is to automate the coordination between the agents themselves. The Agent Handshake Protocol creates a central file where agents coordinate directly. Every agent has a strict role. A fast operator runs pipelines, while a capable architect plans refactors. Conflict is avoided through a one-writer rule. Agents lock files during edits, mirroring logs to proceed. These file-based rules create an environment where agents can work on the same repository simultaneously. The coordination overhead for the human owner drops to near zero because the agents are managing their own boundaries. With coordination automated, you can enable auto-release mode. This is an experimental loop where the operator grinds out new features and the architect acts as a strict quality gatekeeper, only allowing a version bump if the changes provide a measurable improvement. This degree of autonomy requires mandatory safety rails. The loop is constrained by rigid rules. Agents must create snapshot branches, pass every automated test, and wait for human approval before code reaches main. This loop demonstrates that when you provide enough structure, AI agents can independently manage the iterative development lifecycle while staying within the guardrails designed by the human architect. Looking back, this project didn't start with an ambition to build a new protocol. It started with the frustration of a single developer trying to fix a broken node. But by documenting those specific personal friction points, the process naturally generated open-source infrastructure. Solving a private problem created a public utility that others can use to stabilize their own work. It suggests that creative practice is about more than the final output. It's about designing the underlying systems that help other people think, build, and solve problems with more confidence. This shift from isolated chat windows to shared logs changes our relationship with these tools. By moving the interaction into the repository itself, we stop treating AI as a solitary assistant and start treating it as a component of a larger system. We are entering a framework where humans and machines are aligned through shared protocols, building together within a collaborative medium that spans across different models and platforms. By architecting these systems of coordination, independent creators are empowered to build with a level of autonomy that used to require a full engineering team, allowing them to focus less on the friction and more on the work itself.